Graph 3, we have a speed time graph, and if we do an Oizerga analysis, we have 10, 8, 6, 4, 2, 0, so that's 0, and we're dropping by 6s and 0, so we are at the origin. Y-axis is speed, and again, we always want to be careful of speed, but it's in normal units. So v, speed, x is time, normal units, so therefore any questions about speed and time, we'll read off the graph. The gradient is delta v over delta t, which is the acceleration. We want to keep in mind that's the scalar acceleration. No direction is indicated. And the area is v delta t, which is speed times time, so it's going to give us the distance traveled, not the displacement. So looking at the question, a straight level road of this truck, to determine the distance during the 10-second time interval shown below. So what we're really looking for the area. So we're going to multiply the average speed of 18 meters per second by 10 seconds travel time. Well, we know average speed is distance over time, and so the distance is the average speed times the time. So if the 10 seconds is true, it is 10 seconds. It is 10 seconds. And is the average speed 18? We start at 30, we end at 6. So 30 plus 6 over 2 is 18. So it looks like that's a valid method. Multiply half the initial speed of 30 meters per second, which is 15, which is here, by the 10 seconds travel time. Well, these two both can't be correct. And so when you look at this, the question is, does it come down, is the 15 the one we use or the 18, and the 15 is simply not the average velocity. So B is out. Calculate the slope of the line, well, that's the acceleration, and then use d equals 1/2 at squared. Well, d equals 1/2 at squared is a valid formula, but in its full form, it's 1/2 at squared plus v0t. We have to take into account the initial velocity, and the initial velocity is not taken into account if we use that equation, so this cannot be correct. And then, of course, we look at choice D, calculate the area, which is the first one we were looking for.